All right, so here's the question, right? What is our new trajectory if we slow down at that x? Okay, so let's, we need a circular orbit and we're going to slow down on the left side. So let's find that. Let's go here, put it in orbit. Let's let it make a full circle, okay? So here it is, halfway. And then the next time it gets over on that left side, I'm going to hit the R key, which just slows down the velocity. It's the retro rockets. They're like, 1950s rockets. Okay, are we ready? I just hit it 5 times there. They should count them. Notice it brings that far side in. Interesting thing, right? It brings that far side in. And when it's closer to the planet, it's actually going faster than it was in the old orbit. And here it's going slower than it was in the old orbit. Notice that the two orbits are tangent to each other at that one point where I fired the rockets. So, one way to picture this is what the marble in one of those sort of cone-shaped things, right? The gravity well things. The marble, when it rolls down, goes faster, slows down when it gets farther away, right? Okay, so I imagine this like this. It just brings that far side in. And that's always the case. If you're ever slowing, it always brings the far side in. We fired the rockets here. It'll be tangent there, but it brings that far side in, which is a bit counterintuitive. And one way to think about it is, well, I guess we have less, if we use the F word, less centrifugal force, right? So therefore gravity's stronger. Gravity pulls it in. When it pulls it in, it's kind of like pulling your arms in on those gates at IBOC Park, right? It speeds you up, which then flings you out. That's one way to think about it. Anyway, there you have it.